Right now, as you sit there, you are connected to every galaxy in the observable universe. Not metaphorically, not poetically, physically. By a structure so vast, so ancient, and so invisible that scientists spent decades not even knowing it was there. It has a name, the cosmic web, and once you see it, you cannot unsee it. Here's the thing about the universe most people get wrong. They imagine it the way old textbooks drew it. Galaxies scattered randomly like dust thrown across a black sheet. Some closer, some further. Chaos with no pattern. But that picture is wrong. Badly wrong. Because the universe at the largest scale anything has ever been mapped is not random at all. It is structured. It is organized. And the structure it has chosen looks almost exactly like something you have seen before. Right inside your own skull. The cosmic web is a vast network of filaments. Enormous threads made of dark matter and gas and light, stretching hundreds of millions of light years in every direction. These filaments connect galaxy clusters the way nerves connect organs. At the intersections where filaments cross, you find the densest concentrations of matter in existence, superclusters, cities of galaxies, each one containing thousands of individual galaxies, held in place where two or more of these cosmic threads have wound together over billions of years. Between the filaments, there is almost nothing. Enormous voids stretching hundreds of millions of light years across, containing barely a handful of lonely galaxies drifting in near total emptiness. The universe is not a scatter, it is a web. The story of how we found it starts in the 1980s, with a pair of astronomers named Margaret Geller and John Hutra at the Harvard-Smithsonian Center for Astrophysics. They were doing something almost mundane by the standards of modern astronomy. They were mapping galaxies, plotting their positions in three-dimensional space to see if any patterns emerged. What emerged was not a pattern. It was a revelation. The galaxies did not spread evenly. They arranged themselves along thin, curved surfaces, great walls and sheets and filaments, with enormous empty bubbles of space between them. Geller and Hutra had accidentally discovered the large-scale structure of the universe. They called one particularly striking feature the Great Wall, a sheet of galaxies stretching 500 million light-years across, one of the largest known structures in the universe at the time. The scientific community was stunned. Nobody had predicted it would look like this. But it gets stranger, because when cosmologists ran computer simulations of how the universe should have evolved after the Big Bang, starting with the tiny quantum fluctuations in the early universe and letting gravity and dark matter do their work over 13 billion years, what came out of the simulation was the cosmic web. Every time, the mathematics demanded this structure. The filaments, the voids, the nodes. It was not a coincidence. It was the universe solving an equation, and the answer it kept arriving at looked disturbingly familiar. In 2016, a neuroscientist named Franco Vazza at the University of Bologna and a neurologist named Alberto Folletti published a paper comparing two images side by side. One was a simulation of the cosmic web. The other was a section of the human cerebral cortex, the outer layer of your brain where thought, language, and memory live. The structural similarity was, in their words, remarkable. Both systems showed the same kind of filamentary networks, similar clustering behavior, similar ratios of dense nodes to empty space. The scales are incomparably different. The brain operates across millimeters. The cosmic web operates across hundreds of millions of light years, but the organizational principle, the way complexity arranges itself when given enough time and the right rules, appears to be the same. You are not just made of stardust. The architecture of your thoughts may mirror the architecture of the cosmos itself. Now, here is what makes this more than a poetic comparison. The filaments of the cosmic web are not just structural, they are highways. Matter flows along them. Gas streams from the empty voids toward the filaments, down the filaments toward the nodes, where galaxies form and grow. Your own galaxy, the Milky Way, sits inside a filament called the laniakea supercluster, a name taken from the Hawaiian for immeasurable heaven. Laniakea was only mapped in 2014 by astronomer R. Brent Tully and his team at the University of Hawaii. It contains the mass of 100 million billion suns and stretches 500 million light-years across, and it is just one node in a larger web, a neighborhood in a structure that goes on in all directions, further than any telescope has yet reached. You have never seen Laniakea from the outside. No human ever has. But if you could, you would see a shape like a beating heart with matter flowing inward along filaments from every direction toward a central gravitational point called the Great Attractor. A point that, incidentally, everything in Laniakea, including you, is being slowly pulled toward at roughly 600 kilometers per second. You are not standing still. You are falling gently across the largest structure your galaxy has ever known. So, what holds all of this together? What built the web in the first place? The answer is something you cannot see, cannot touch, cannot detect with any instrument currently in existence. Dark matter, an invisible form of matter that makes up roughly 27% of the total energy content of the universe, compared to the 5% that makes up everything you have ever seen, touched, or measured. Dark matter does not emit light. It does not absorb light. It does not interact with anything except through gravity, but it is everywhere, and its gravitational pull was the scaffold around which the cosmic web assembled itself. The ordinary matter, the gas and dust, and stars and planets in you, simply fell into the structure dark matter had already carved out. The web existed before the galaxies. The galaxies grew inside it, the way moss grows on a stone wall. This means something unsettling. The universe you can see, the 100 billion galaxies, the billions of stars in each, every planet, every ocean, every living thing that has ever existed anywhere, is a thin frosting on a structure you cannot see. The real skeleton of the universe is invisible, and it has been quietly shaping everything since the first few 100,000 years after the Big Bang. Here is the part that brings it back to you. The cosmic web is still growing, still evolving. The filaments are still pulling matter in from the voids. The voids are still growing emptier. The dense nodes are still accumulating more and more mass. This is not a static picture. It is a living process, playing out across scales and timescales so enormous that a human lifetime is not even a rounding error, and yet you are part of it. Every atom in your body was processed inside a star that formed inside a filament, inside a node, inside this web. The carbon in your cells was forged in a stellar furnace that itself formed because a thread of dark matter, hundreds of millions of years old, happened to concentrate gas in exactly the right way. You are not separate from the cosmic web. You are one of its outcomes. And the next time you feel overwhelmed by the scale of the universe, by how small and brief and unlikely your existence seems, consider this. The same force that organized 100 billion galaxies into a single interconnected structure also organized the matter in your brain into a network of 100 billion neurons. The same patterns appear at both ends of the scale. The universe did not make you by accident and then leave you outside it. It made you by the same process and by the same rules that made everything else. You are not a visitor to the cosmos. You are an expression of it, a piece of the web that somehow became conscious enough to look up and wonder what it was part of. Right now, as you sit there, connected to every galaxy in the observable universe, the web you are made of is thinking about the web that made it.